So first thing that we need to do is what?
Find x and y.
Find x and y. So what's x? X is our cosine theta, so that'll be sine 4 theta cosine squared theta. And y will be sine 4 theta cosine theta sine theta. Oh, that's going to be a pain, isn't it? How can we rewrite y?
Sine of 2 theta over 2.
Sine of 2 theta over 2 for this part of it, and then we'll still have a sine.
Oh yeah, multiplied by. Yeah,
1/2 sine 4 theta sine 2 theta. That's going to make life a lot easier when we try to take the derivatives of this, I believe. Well, actually, I know. So let's do this. Let's see here. I'm trying to get another color. Oh no, the toolbar disappeared. It was there, now it's gone. There we go. All right. So first off, let's figure out what the x coordinate and the y coordinate are. So x should be sine of 2 pi over 3. What's the sine of 2 pi over 3? What's the sine of 2 pi over 3?
Root 3 over 2.
Root 3 over 2. And then the cosine of pi over 6 is root 3 over 2. So we're going to square that. So that'd be root 3 over 2 squared. That's going to give us what? 3 root 3 over 8. Everybody good with that?
Yeah.
Okay. And then what about y? Y is going to be 1/2 the sine of 4 pi over 3. So that's 1/2 of root 3 over 2. And then the sine of pi over 3. What's the sine of pi over 3? Also root 3 over 2, right? So that's going to give us just 3/8. And now we need to find a derivative. So dy d theta ought to be the derivative of this. So that'll be 1/2 sine 4 theta times 2 cosine 2 theta plus, and then that'll become 2 cosine 2 theta sine 2 theta.
Isn't it 2 cosine 4
cosine
theta?
4 theta, yeah, 4 theta. Sorry, yeah, I realized that, and then yeah, 4 theta. Everybody good with that? And then our dx d theta ought to be sine 4 theta times the derivative of the cosine 2 theta, which is 2 cosine theta times negative sine theta. And then plus 4 cosine 4 theta times cosine squared theta. And I don't really care if we simplify this down, so let's just plug in our pi over 6 value. So we got 1/2, and the sine of 4 pi over 6, like we said before, is root 3 over 2. We got a 2. And then we got a cosine of pi over 3. What's the cosine of pi over 3?
1/2.
Half. We got plus 2 times our cosine of 2 pi over 3. What's the cosine of 2 pi over 3?
Negative 1/2.
And then the sine of pi over 3 ought to be what? Root 3 over 2. Yeah. And then in our denominator, we got that sine of 4 theta again, which ought to be another root 3 over 2. And then a 2. And then our cosine of pi over 3, which is a half. Sorry, cosine of, that's just cosine theta. cosine of pi over 6, which ought to be √3/2. And then a -1. And then a sine of pi over 6, which is 1/2. And then our 4. And then our cosine of 4 pi over 6, which is cosine of 2 pi over 3, which is -1/2. And our cosine squared of pi over 6. So cosine of pi over 6 is √3/2. So √3/2 squared. Everybody good with all those values we plugged in?
Yes.
All right, those ones cancel. 2 and the 1/2 will cancel. Cancel out a 1/2 and a 2. Cancel out a 1/2 and a 2. Oops, let's not do that. Let's cancel out this 2 in the denominator with this 4 because that 2 is getting squared. And then we'll put it all together. So now we got √3/4 minus √3/2 all over, let's see, this is -3/4. And then this is minus 3/2. And what does that give us? √3/4 minus √3/2 ought to be -√3/4. And -3/4 minus 3/2 ought to be what? Should be minus 9/8. I mean, minus 9/4. Why did I say eighths? Minus 9/4, which gives us -√3/9, which is √3/9. Everybody good with that or no?
Yeah.
All right. Y minus 3/8 equals √3/9 times x minus 3√3/8. Let's take a look at it on Desmos. So we have R equals sine 4 theta times what? Times sine theta or times cosine theta? Cosine theta, right? There we go. So there's our function, and what do we have? We had y minus
3/8.
3/8. And we had what? √3/9 was our slope, I think. And x minus, what was it? 3√3/8.
Yeah.
Cool. And that was pi over 6, which, you know, if we were to put in, we can't really put in theta equals pi over 6. We could put it in what would that be? That'd be y equals x √3/3. If you put that into, there's the angle, right? Hitting it right there at our point where theta equals pi over 6 on our function. The blue line is tangent to it. And I just put the equation theta equals pi over 6 into a rectangular linear equation. That's how I got that green one. But the blue one is our tangent line at that point. Everybody good with that? Any questions on that or no? All right, I'm going to assume that means you're all okay.
Yeah.
All right, great. So now we need to talk about horizontal and vertical tangent lines. So a horizontal tangent line, we should know, occurs when the derivative is 0. and a vertical tangent line when the derivative is undefined. Right? So you guys take a second and find vertical and horizontal tangent lines for each of these two functions. Everybody good on, you remember that from previous years? Previous studying of calculus, right? Okay, great. All right, so take 2 minutes and find the horizontal and vertical tangent lines for those two equations. Figure out when the derivative is 0 and when the derivative is undefined. Ready, go. So first one, find the derivative. What was your derivative? Should be 6x squared minus 6x. And that's never undefined. It's polynomial, right? Polynomials will never be undefined. And it equals 0, take out the 6x. If 6x times x minus 1 is 0, so x equals 0 and x equals 1. And if we're looking for the actual tangent lines, what do we need to do? Plug those back in. So f of 0 is 5 and f of 1 is 4. So we should get y equals 5 and y equals 4. Everybody good with that one?
Yeah.
All right. And then this one, cube root of x plus 5 minus x. And that's x plus 5 to the 1/3, which ought to be 1/3 of x plus 5 to the negative 2/3 times the derivative of x plus 5, which is just 1. And then minus 1 for the minus x. So this is 1/3 times x plus 5 to the 2/3 minus 1. And we get a common denominator. And we end up with 1 minus 3 times x plus 5 to the 2/3 over 3 times x plus 5 to the 2/3. And when does this undefined? When x is negative 5. And that would be the vertical tangent line. And when does it equal 0? When that numerator equals 0, right? We also need to figure out when does 1 equal 3 times x plus 5 to the 2/3. Well, that'd be when 1/3 equals x plus 5 to the 2/3. Or we'd have to cube this and then square root it. So that'd be the square root of 127 equals x plus 5. So negative 5 plus the square root of 127 is the location of that. And if we wanted to figure out what it actually was, we could plug it in up there, but I'm not going to. That's a little bit annoying. Any questions on that?
Nah.
No, everyone's okay with that. All right, cool. What about for something like this nice, easy, implicit equation? Take our derivative, right? 2x plus product rule on that, x dy dx plus y plus 2y dy dx equals 0. And solve for dy dx. So we got 2x plus y. On this side, if we bring those over, negative x minus 2y, it will divide by. And how do we figure out when this numerator is equal to 0? Tells us that y is equal to negative 2x, right? True? what do we do with that to figure out when that's true?
Plug it into the original equation.
Yeah, we plug that into our original. Now, if I plug that into the original, I'm going to get an answer out in terms of x, right? And I'm looking for horizontal tangent lines, so it might be better if I solved it for x first and said x is equal to negative 1/2 y and plugged that in instead. I think that'll make life a little bit easier. So if x is negative 1/2 y, negative 1/2 y squared ought to be 1/4 y squared. And then minus 1/2 y squared, and then plus y squared equals 6. So 1/4 minus 1/2 is negative 1/4, plus 1 is 3/4. So 3/4 y squared equals 6, or 24 divided by 3 is 8, y squared equals 8, or y is plus or minus 2√2. Good or no?
Good.
All right, and then for this one, negative x minus 2y needs to equal 0. We're going to want this one, since it's vertical tangent lines, all in terms of x. So if we solve this for y in terms of x, we end up with y equals negative 1/2 x. And I think you could probably see that if we plug that in, we're going to get x squared minus 1/2 x squared plus 1/4 x squared equals 6. And that's going to give us the exact same thing, right? 3/4 x squared equals 6, or x equals plus or minus 2√2. Yeah?
Yeah.
Everybody agree there? Okay, so if we take a look at this in Desmos, we had what? X squared plus xy, right? Plus y squared equals 6. Got a nice little ellipse turned on its side. And we got y equals 2. Well, yeah, we'll do 2 square root 2. That didn't turn out right. 2 square root 2. There's 1. We got y equals negative 2 square root. I can't type today. Negative 2 square root 2. There's the other one. We got x equals 2 square root 2. And x equals negative 2 square root 2. And there are all of our horizontal and vertical tangent lines for this ellipse. Good or no?
Beautiful.
Wonderful. All right. That's it for today.